All right, howdy everybody. Sorry we can't be together, but hopefully this will work in place. So let's get started with joke of the day, because it's been a long time since we've had joke of the day. I kind of miss it. So why should you never use a dull pencil? Because it's pointless. That's a good one. I like that. Okay, here's another one. I know some people hate math, but you've got to admit decimals have a point. These are good. Okay, last one. A Spanish magician tells the audience that he will disappear on the count of 3. He says, uno, dos, and then poof, he disappeared without a trace. These are so good. Okay, so let's get into it. We're going to take a look at section 6.2 where we're factoring trinomials where the leading coefficient is not a 1. Now we looked before at factoring polynomials, and when we did, we said we're going to look at common monomial factoring. And we said with common monomial factoring, what you do is you take a look at every single term, you find out what's common to every term, you divide that common factor out. When you divide it out, you let it sit outside of a parentheses, and you write down inside the parentheses everything that's left. So what happens with common monomial factoring is you're reversing the distributive property. The distributive property allows you to multiply things through the parentheses. And so the common monomial factoring reverses that. So basically common monomial factoring is dividing your polynomials. Well, we're going to continue with factoring. So we're going to continue dividing our polynomials. But this time what happens is you've got a polynomial, more specifically a trinomial. And recall, trinomials have 3 terms in them. And so what we're going to do is look at these trinomials. They are not going to have anything common that can be divided out, or maybe they will. But once you get to the point where there's nothing common that you can divide out, you can still factor them. In this case, what happens is you end up reversing FOIL. Now recall, FOIL is a situation where you have a pair of parentheses. You have a double parentheses like you see here. And within those parentheses, you're going to have a pair of binomials. So you have a binomial here, and you have a binomial here. Recalling that binomials have 2 slots in them, or 2 terms in them. So when you reverse that FOIL, and you're starting off with this trinomial, the way that you factor it is you take a look at this first term here. The first term splits up into these first slots. So you're going to ask yourself, what would I multiply together to create this ax squared? And that will go in each of these first slots. Then you'll look at the back term here, and you'll split it up into the back slots, here and here. So again, you'll say, what would I multiply together to create this back term? That goes into each of these 2 slots. Now binomials are polynomials, therefore their terms are separated by addition and subtraction. So that means you're either going to have an addition sign here or a subtraction sign, and the same thing here, an addition sign or a subtraction sign. So now the key is trying to figure out what those signs are going to be. There's actually a fairly easy way to do that. First you look at the back sign of the trinomial. That's this one right here. Now what the back sign does is it tells you whether they are the same signs or different signs. Same signs or different signs. So if this back sign is a minus, now think about what's happening here. If you saw these pair of binomials here, the double parentheses, and you didn't see anything else, you would know that you need to FOIL that. And when you FOIL it, you'll multiply first times first. That'll create this one. You'll multiply the outsides and the insides. Those 2 will combine to create the middle term. You'll multiply these back slots. That will create this back term. So what I'm getting at is, if this is a minus, and this back term right here comes from these 2 back terms, then these 2 have to multiply to create that. If this is a minus, then the only way for it to be a minus is if these 2 are going to be opposite signs. If they are the same sign, when they multiply together, they become a positive. So for this to be a negative, like you see right here, these have to be opposite signs. So if it's a minus, then the signs are going to be different or opposite. If this is a plus, like you see here, then like I said, what happens is these 2 multiply to create that. So they have to be the same. Either they're both pluses, because a positive times a positive will be a positive, or they're both negatives, because a negative times a negative will give you a positive. So if that back sign is a plus, then that tells you that they are going to be the same sign. Well, then the question is, what is that sign? Are they both positives or are they both negatives? Again, that's pretty easy to figure out, because once you've determined that you have the same sign, to figure out what the signs are, you look at this middle sign right here. So it will tell what they are. So in other words, if this middle sign is a positive, that tells you that they are both positive. If this is a negative, then that tells you that they're both negative. And there, that's how you do it. So once you've determined, let me go back and fix these. These are positive or negative, and a positive or negative. So once you've determined and you factored it out, how would you be able to check to make sure you're right? In other words, once you've filled in all of this that's in blue, how would you know that you've got that set up correctly? Fairly easy, you're right. You would just check it by FOIL. Now, what if it won't factor? What if there is no way to split that up into a double parentheses? Well, if it can't be factored, then the polynomial is considered prime. Think back to prime numbers. You're way back to elementary school when you talked about prime and composite numbers. Prime numbers, like say for instance is 17. Why is 17 prime? Yeah, because it can only be divisible by 1 and itself. 6 is not prime, because it can be divisible by 1 and 6, but it also can be divisible by 2 and 3. So 6 is considered to be composite. So prime numbers are numbers that cannot be split into factors. And so therefore, if you have a polynomial that cannot be factored, it's going to be considered prime as well. So this is how it operates. Let's take a look at several. I've got lots of examples here to practice what we just described. So in our first example, we are going to, in all the examples, we're going to factor each. And let's start with an a squared plus a 13a plus a 36. Now, you need to always look first to see if there's something common to every single term that you can divide out before you do anything else. As I look at my a squared, 13a, and 36, is there anything common to each one of them so I can do the common monomial factoring? Well, coefficient of 1, 13, and a 36, there is no number that will go into all three of those. And it has to be divided out of all three of them. This has an a squared, that has an a, but this doesn't have an a. So I can't divide the a's out because, again, it has to come out of all three of them. So what I'm going to do then is I'm going to attempt to set up that double parentheses. And within the double parentheses, first I'm going to look at the signs. It's much easier if you fill in the signs first. So I'll look at the back sign here. It being a positive, that tells me that these two signs are going to be the same. Now I'm going to figure out what are they going to be. That comes from the middle sign. It's a plus, so that tells me that both of these are going to be pluses. Now I start splitting up the slots. Remember, this splits up into the first two slots. So I ask myself, what would I multiply together to get an a squared? Well, that would be an a and an a. So this is an a and this is an a. Now I need to split this up into the back two slots. So I'm looking for numbers that will multiply to be a 36. Now there's lots of options there. It could be a 36 and a 1. It could be a 12 and a 3. It could be an 18 and a 2. It could be a 9 and a 4. It could be a 6 and a 6. Lots and lots of options here. So what I need to think through is the fact that when I check this by FOIL, remember that I'm going to multiply this times this. First times first will give me the front slots, or the first term of my trinomial. But remember, when I multiply out here, I'm going to get a positive something A. And when I multiply in here, I'm also going to get a positive something A. Those two are going to combine by addition because these signs are the same. So whatever numbers are in here, I'm going to add those two numbers up. That's a clue to me. And when I'm trying to find the numbers that will go here, those two numbers will multiply to be a 36, but because of this FOIL here, they're going to add to be this middle term here. So of this set here, what two numbers would multiply for 36 and add for a 13? Yeah, that would be the 9 and the 4 right there. So that tells me that I'm going to put a 9 in one spot and a 4 in the other spot. It really doesn't matter which spot they go in because I'm going to check this by FOIL. And again, A times A will give me A squared. When I multiply out here, I'm going to get a 4A. Now I'm going to continue with FOIL on the insides and get a 9A. And in the back, I'm going to get a 36. And like I said before, these two middle terms here, I'm going to combine up. And they do combine by addition, so I'll get an A squared plus a 13A plus a 36. Is that what I started with right up here in blue? Yes, in fact it is. This is not the answer though. This is simply the check. The answer is the factored form, and factored means I have things that are multiplied together. Now granted, there's an addition in here, and there's also an addition in here, but notice that it's parentheses times parentheses. So I actually do have two things being multiplied together. It is the parentheses that are multiplied together. So this is my answer. There's the factored form. Okay, let's try another one. Just write it down here. And I'm going to go with an x squared plus a 12x plus a 32. Doing the very same thing. I'm going to factor it. And remember, you always look first to see, is there something common that you can divide out before you do anything else? Now, I can take x's out of here, but I cannot take an x out of here. So I can't take the x's out. 12 and 32, certainly I could divide 2 into both of them, and that's pretty good, but I can't divide a 2 out of this coefficient of 1. And it has to come out of all three of them. So I know that I cannot factor anything out that's common to every single term. That tells me, let's go ahead and shoot for that double parentheses here. Once again, fill in the signs first. That's much easier. So look at the back sign here. It's a positive. And remember, I'm going to split this up back here. So the fact that this is a positive means these have to be the same signs. Now, what are they? Look at this one. That tells me they're both pluses. So I'm going to split this up into the front two slots. What would I multiply together to get an x squared? That would certainly be an x and an x. Now I want two numbers, split this up into these back slots. So these two numbers here will multiply to be a 32. And like we said up there, because these signs are the same, and when I FOIL, I'll get an x squared. But out here, I'll get a plus something x. And here, I'll get another plus something x. These two will be combined up by addition since the signs are the same. So these two numbers need to multiply for 32 and add for a 12. What two numbers would multiply for 32 and add for 12? That definitely is going to be a 8 and a 4. And 8 and a 4, sorry. And so I can check that by FOIL, and out here I'm going to get a 4x, and here I'm going to get an 8x, and in the back I'm going to get a positive 32. These two do combine to be that 12x. And so that does, in fact, give me what I started with, the x squared plus 12x plus 32. So I know that this is right. And once again, the answer is not the check. The answer is right here. All right. So let's try a couple more here. Change it up a little bit on the signs. Let's go with a v squared minus an 18v plus 80. And I'm going to do the very same thing. I'm going to check first to see is there anything common to each and every term that I can divide out. It's got to come out of all of them. Take v's out of here, but I can't take a v out of there. I can certainly divide both of these by a 2, but I can't divide that by a 2. So therefore, I'm not going to be able to do common monomial factors. So I'm just going to go ahead and try for that double parentheses. And yet again, I'm going to fill in the signs first. Looking at this one, it tells me since it's a positive, that means the signs are the same. What are they? Look at this one. That tells me that they're both negatives. Because remember, I'm going to multiply back here in the FOIL, and that's going to create this. And on the outsides here and insides here, that will create the middle term. So I'm going to split this up into the first slots. What would I multiply together to get a v squared? That's a v and a v. And now again, two numbers that are multiplied for 80, and once again, because those signs are the same here, when I FOIL it, I'll get a v squared. Out here, I'll get a negative something v. In here, I'll get a negative something v. And notice again, because these signs are the same, when I combine these two, even though they're both negatives, I'm actually going to add the numbers, add the digits, in order to create this middle term here. So that's why these two numbers need to multiply for 80, add for an 18. What two numbers would those be? That's going to be an 8 and a 10. So now when I check it by FOIL, v times v will give me v squared, and v times negative 10 will give me a negative 10v. On the inside, negative 8 times v is a negative 8v, and in the back I'm going to get a positive 80. So that when I combine these two middle terms here, sure enough, I do get a negative 80v. And like we said before, this is exactly what I started with. Oh, sorry. My apologies. That's a negative 18. Excuse me. So since I got what I started with, I know that it's right, and I know, in fact, that this is the right answer. There's my factored form. All right, let's give it another shot. So let's try m squared minus 7m plus 12. And again, first, always look to see, is there something common that you can divide out before you do anything else? M's come out of here, but not here. And nothing's going to come out of any of those coefficients. So let's go ahead and set up our double parentheses. This here tells me that the signs are the same because it's a positive. This tells me they're both minuses. So I'll split this up into the front slots. What would I multiply together to get an m squared? That would certainly be an m and an m. And just like before, because these signs are the same, these two numbers here will multiply to be 12. They will add to be the 7 because of the very same reason I described up there. So the two numbers that are multiplied for 12 and add for 7 is going to be a 4 and a 3. And all you have to do is check it by FOIL. So when we do that check, m times m will give me m squared. M times negative 3 is a negative 3m. Negative 4 times m is a negative 4m. And negative 4 times negative 3 is a positive 12. When I combine these two middle terms, notice, like I was saying before, this is why this tells me that these are both minuses. Because when I combine these, and it also tells me that these two have to multiply to be the 12 and add for the 7, because I'm going to add those two digits and get a negative 7m. Is this what you started with? Yep, sure is. So that tells me it's right. And again, this is the check. That's not the answer. Here, the factored form is the answer. Hopefully you're noticing something. Hopefully you're noticing that when you do the check, and notice here on this check, it's not really that important that you check the full FOIL. I don't necessarily need to check first times first, because v times v better be v squared. That's how I got the two v's. And also, I don't necessarily need to check the back here. Negative 8 times negative 10 better be a positive 80. That's how I split it up. What's really the main concern here is going to be these outsides and insides that you see right here. That's the main part of the check that you need to see to make sure that when you multiply outsides and insides, you do get that middle term. Same thing down here. It's not so much the m squareds that I'm worried about, or the back here with the positive 12. It's these outsides and insides that you see. That's where you need to check to make sure you do get the middle term that's up there. So this is what it looks like when that back sign is a positive. Let's switch it up a little bit and see what happens when that back sign's a negative. Then what happens? So in this, again, nothing common that I can divide out of every single term, so I know I'm headed for that double parentheses. And once again, I'm going to fill in the signs first. Now, this is not a positive like you see here. This positive down here indicated the signs are going to be the same, but because this is a negative, I'm going to have opposite signs. Because remember, on this FOIL, when I multiply these backs, I need to create a negative 21. They have to be opposite signs to multiply to become a negative. Now, I'm going to split this up into the first slots. X squared only splits up as an x and an x. And I want two numbers that are multiplied to be a 21. Well, the only two numbers that are multiplied, there's two sets. One is a 21 and a 1, and one is a 7 and a 3. That's all you can multiply together to get a 21. But the catch is, the two numbers need to combine in such a way that I create a negative 4. They have to create by subtraction. That is because when I FOIL this, and I do first times first, that'll work out beautifully as an x squared. But out here, I'm going to get a negative something x. In here, I'm going to get a positive something x. Since these two signs here are different, that means I'm going to combine these numbers, not by addition like we did here. I'm going to actually take the smaller from the larger. Go back to the sign numbers that said when I'm combining two numbers and the signs are different, I take the smaller from the larger, take the sign of the larger. Well, the concept of taking a smaller from a larger is subtraction. So that tells me these two numbers need to multiply for 21. They need to subtract for the 4. So from these combinations that you see right over here, which set will multiply for 21, subtract for 4? Yeah, that's the 7 and the 3. So one's going to be a 7 and one's going to be a 3, and I'm not entirely certain which way it goes. So I'm going to check with FOIL to see if I've got that set up right. So when I do the full FOIL, x times x is x squared, and it better be. And x times negative 3 is a negative 3x. 7 times x is a positive 7x, and in the back, just to be certain, positive 7 times negative 3 is a negative 21. Recall that it's not so important that you check here in the front or in the back. It's right here with those middle terms that I need to worry about. And a negative 3x plus a 7x gives me a positive 4x. Now the problem with that is, I'm going to go ahead and carry the rest of this down. I need to get exactly what I started with. It's close, but not quite. Because notice here, that's a negative 4x, that's a positive 4x. When you have the right number, wrong sign, that is very easy to fix. All you have to do is switch out these signs. So this will become the negative, and this will become the positive, because what happens is, now when I multiply outside here, I get a positive 3x, and when I multiply inside here, I get a negative 7x. That creates a negative 4x right there. Now that is exactly what I started with. So I know that the check is right, which tells me that these are the right factored form. So like I said, whenever you have a minus back here, that tells you you want different signs, and that tells you that these two numbers need to multiply for that and subtract for the middle one. All right, let's try another one. How about a y squared minus 5y minus an 84. So again, look first to see if there's anything common that you can divide out before you do anything else, and there's not. So I'm going to try to set up that double parentheses. And I'm going to fill in my signs first because that makes life a whole lot easier. So this tells me my signs are going to be different. One's a plus, one's a minus, and as you saw up here, if you've got them in the wrong place, that's okay. You can switch those signs up. So just put them in there and give it a shot. I'm going to split this into the first slot, so I'll multiply a y times a y to give me y squared. And now I want two numbers that will multiply to be 84. Because they are different signs, they're going to subtract to be that 5. So the two numbers that will multiply for 84 and subtract for 5 are going to be a 12 and a 7. Now granted, 84 splits up in many other ways. It splits up as, say for instance, a 42 and a 2, splits up as an 84 and a 1, splits up as a 21 and a 4. Lots of different combinations. But like I said, the combination that will work is the combination that not only will multiply to be 84, but it needs to subtract to be 5. And like I said before, that's going to be your 12 and your 7. So we've got to figure out which one's which. So put the 12 in here, put the 7 in here. Like I've said, hopefully at this point you're understanding that I don't really need to check the first. Those better become a y squared. That's how you split it up. Don't really need to check back here. A 12 times a 7 better be an 84, and a positive times a negative is going to be a negative. That's how you split it up. It's the outsides and the insides that you're worried about. So outside I'm going to get a negative 7y, inside I'm going to get a positive 12y. Those combine to be a positive 5y. Once again, right number, wrong sign. Super easy to fix. Just switch those signs out. Make this the negative, make this the positive. That will turn this into a positive 7, this into a negative 12, this into a negative 5y. Now I've got the right number, right sign. So I know that at this point, this is the right answer. There's my factored form. Okay, one more, and then we're going to switch the game just a little bit and make it slightly more complicated. All right, let's go with a p squared minus a p minus a 56. Now, there's nothing common to these that I can divide out, so I'm going to go ahead and head for that double parentheses. Back sign being a negative tells me that I'm going to have opposite signs. Split this up into the front slots, a p and a p. Now, I want two numbers that will multiply to be 56. Because the signs are different, they're going to subtract to be, that's a negative 1. 56 splits up as a 56 and a 1, an 8 and a 7, and it also splits up as a 28 and a 2. But the combination that will actually subtract to be a 1 right here is going to be your 8 and your 7. So toss it in there. And then just check outsides and insides. Remember, you don't have to check the full FOIL. These better be a p squared, that better be a negative 56. So outside here, I'll get a negative 7p. Inside here, I'll get a positive 8p. Those combine to be a positive 1p. But I wanted a negative 1p. Really easy to fix. All I'm going to do is switch these signs out, make this the negative, make this the positive. That changes this to a positive, changes this to a negative, changes that to a negative. Now I know that that's the right answer. So that's the basics of factoring trinomials when that leading coefficient is a 1. However, you do have cases where the leading coefficient might not be a 1, but you can turn it into a trinomial where your leading coefficient is a 1. Say, for instance, you've got a 3x squared plus a 21x plus a 36. Now recall, every single one of these I have said, how do you begin? You always, 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 always look first to see if there's something common that you can divide out before you do anything else. We just haven't seen a case of that yet. However, on this one, notice that with 3, the 21, and the 36, is there a number that I can divide into all three of those? Sure, it's a 3. So I'm going to do that common monomial factoring that we talked about in the last section. I'm going to divide that 3 out, and remember, when I divide it out, I'm going to write down what's left inside the parentheses. Notice that I can take x's out of here and here, but I cannot take x's out of here. So I'm stuck with only dividing the 3 out. Now when I divide it out of here, I'm left with an x squared. Divide it out of here, I'm left with a 7x. And divide it out of here, and I'm left with a 12. Now with factoring, you always look and ask yourself, is there any more that I can divide out? Can I split it up any further? There's nothing more common that I can divide out here. But could I split it into a double parentheses? Let's check and see. If I could, then I know that this would tell me the signs would be the same. Are they both pluses or both minuses? This tells me they're both pluses. Now, just like before, I'll take this and split it up into the front slots. What would I multiply together to get an x squared? That would be an x and an x. Now, what would I multiply together to get a 12 and add to be a 7 because these signs are the same? So that would be a 4 and a 3. So that is how you factor what's in the parentheses into a double parentheses. Notice that if I do check outsides and insides, out here I get a positive 3x, and here I get a positive 4x. Those do combine to be that positive 7x that was right here. However, I need to be able to multiply it out and get all the way back to the beginning. So if I FOIL this, that'll only take me to here. I need to get all the way back up to here. That's why this 3 that sits out front, I have to keep it in there. I can't lose it. It is very important and part of my answer, because without it, I won't get back to the beginning. So my actual answer, my factored form, is going to be all of this, including that 3. Because now when I FOIL this, I get back to here. When I distribute the 3 through, I get all the way back to the beginning. And so I know that that answer is right. All right, let's practice just a couple more of these, and then that will wrap up this section. Let's try a 2x squared plus a 10x minus a 48. Once again, look to see, is there something common that you can divide out of every single term before you do anything else? I do notice that with that 2, the 10, and the 48, they're all divisible by 2. So I'm going to divide that common 2 out and write down inside the parentheses what's left when I do that. 2 divided out of the first term gives me x squared. 2 divided out of the 10x gives me 5x. And negative 48 divided by 2 will give me a negative 24. Now again, I always look and ask myself, can I take that any further? Can I factor this anymore? And I certainly can. Notice that I can set up a double parentheses here. This back sign tells me that the signs are going to be opposites. Split the x squared up into the front slots as an x and an x. Two numbers that will multiply to be 24. Because the signs are different, they're going to subtract to be a 5. And that's going to be an 8 and a 3. Just check those outsides and insides to make sure that you've got your signs set up right. This is a negative 3x. This is a positive 8x. Those combine to be that positive 5x that I needed right there. So I know that that's right. But remember, foiling this will only get me to here. I need to get all the way to the beginning. So I need to retain the 2 that's out front. Now, this is full factored form. All right. Just a couple more. (18x squared plus 9xz). Whoa, threw an extra variable in there. Plus a z squared. Having the extra variable in there, will that change things up? Not at all. The process is completely the same. So I will still look at this trinomial and ask myself, is there anything common to every single term that I can divide out before I do anything else? Well, this has x's. This has an x, but that doesn't, so I can't take any x's out. That has z's, and that has z's, but this doesn't, so I can't take any z's out. 18, 9, and a 1, nothing common on those coefficients that I can divide out. So the only thing that I can attempt to do is try to set up a double parentheses, and the process will be the same. In other words, this sign here will tell me whether they're the same or opposite. It's a positive, so they're the same. This will tell me they're both pluses. Now, I will split the 18x squared up into the front slots, but notice this back slot here comes from the z squared, so it goes into the back slots. Shook it up a little bit there. Now, we're switching it up because back here when it looked like this and the coefficient of 1 was in the front, then we said in the back 2 numbers that will multiply to be 24 and subtract to be a 5. Here it's going to be 2 numbers that multiply to be an 18 and add to be a 9. Just kind of working backwards a little bit, but the process is the same. So the 2 numbers that will multiply to be 18 and add up to be a 9 are going to be a 6 and a 3. But notice that when I split this up, I got to split up the x squareds as well. So it'll be a 6x and a 3x. If you doubt yourself, just simply check it by FOIL. So and it might be a good idea to do the full FOIL here because of those extra variables to make sure you split them correctly. So in the full FOIL, 6x times 3x will give me an 18x squared. That's good because that's what I needed. 6x times z will give me a 6xz. And then here, z times 3x will give me a 3zx, which xz, zx, those are the same thing because multiplication is commutative. And z times z will give me a z squared. Now, when I combine up like terms, that's here and here because remember, zx and xz are the same thing. Those combine to be a positive 9xz. And so nothing else combines. Is this what I started with? It sure is. So that tells me that what I have written here in black actually is the right answer. Okay, well, those extra variables threw us a little bit, so let's try a couple more. How about a squared b squared plus ab minus 6? Now, is there anything common to each one of these that you can divide out? I got A's and B's here, A's and B's here, but no A's and B's back there. Coefficient of 1, coefficient of 1, and a 6, nothing common I can divide out. So I'm going to head for that double parentheses here. Back sign here being a minus tells me they're opposite signs. One's a plus, one's a minus, and we've discussed that if that's the wrong order, it's easy to switch it up. Split this into the front slots. Now what would I multiply together to get a squared? Well, an A and an A. What would I multiply together to get a B squared? That's a B and a B. And notice that an AB times an AB is certainly going to be an AB squared. So I'm looking pretty good so far. Now I want two numbers here that are multiplied to be 6. Because the signs are different, they're going to subtract to be that 1 that's in the middle. Now 6 does split up as 6 and 1, 2 and 3. But the only combination that will result in subtraction into a 1 is going to be that 2 and that 3. So we'll fill it in like this. And remember, you can check the full FOIL if you'd like, but what's important is the outsides and the insides. This better become a squared b squared, that's how you split it up. This better become a -6, that's how you split it up. So on the outside here, I'm going to get a -3ab, and on the inside I'm going to get a +2ab. Those combine to be a -ab. Close. I have the right number, it's a 1, but wrong sign. Very easy to fix. Just switch this to a negative, switch this to a positive, because that'll switch this to a positive, and this to a negative, and switch this to a positive. Now I've got the right number, right sign. So know that this is in fact the right answer. All right, last one here, and I think we've got it. X to the third y minus 2x squared y squared minus 3xy to the third. So again, I always look to see, is there something common that I can divide out before I do anything else? Notice that this has x. Oh, they all have x's. So what's the highest x that I can divide out? I can take 3 out of here, 2 out of here, 1 out of here. So the most I can take out is a single x. Take a look at the y's. Y to the first, y to the second, y to the third. Yeah, I can take a y out of all of them. And the biggest y that I can take out is a y to the first. Coefficient of 1, 2, and 3, no coefficients that I can divide out. So I'm going to write down in the parentheses what's left. When I take the x out of here and divide it out, I'm left with x squared. These y's will cancel. Here, when I take an x squared and divide an x out, I'm left with one single x. And when I take a y squared and divide by y out, I'm left with one single y. Here, take the x and divide it out, it cancels. And a y to the third divided by a y to the first is a y squared. So I have done the common monomial factoring, and I've divided out everything that I possibly can. Now I'm going to see, is it possible to split this up into double parentheses? If so, then this tells me that my signs are going to be different. And here I'll split the x squared up as an x and x, and I'll split the y squared up. Now what would I multiply together to get y squared? That's certainly a y and a y. What would I multiply together to be a 3? Well, that's a 3 and a 1. That's the only thing that will work. So try the 3 here, try the 1 here, check your outsides and insides. Out here I get a -1xy. In here I get a +3xy. Those combine to be a +2xy. Well, again, right number, wrong sign. Super easy to fix. Just change that to a negative, change this to a positive. Recalling that I don't really need that coefficient of 1. Now out here I get a +xy, and here I get a -3xy. Those combine to be a -2xy. There we go. That's right number, right sign. But remember, if I FOIL this, that only gets me to here. And I need to get all the way back to the beginning. So it's very important to retain that xy that's sitting out front. This is the full answer. And that, my friends, is how you factor trinomials with the leading coefficient of 1. Notice that even though you may not have a leading coefficient of 1, I've already erased it, but there was a case where the leading coefficient wasn't a 1, but you can do common monomial factoring to create the leading coefficient that's going to be a 1. And then it becomes pretty easy to do. Just check your back sign to tell you whether your signs are same or opposite. If they are the same, this tells you what they are. If this is a minus, then that's going to tell you they're opposite signs. And then you want two numbers that will multiply to be this. If these signs are the same, they're going to add for the middle coefficient. If these signs are opposites, they're going to subtract for the middle coefficient. And that makes it pretty easy. All right, you guys have a good day.